All right, 81. What volume of 0.115 molar perchloric acid is needed to neutralize 50 milliliters of 0.08 molar sodium hydroxide? All right, so with this problem, we've got a neutralization reaction, right? We've got sodium hydroxide reacting with perchloric acid to make water and salt. Sodium perchlorate. So what I need to do here is find a way to get to moles so I can use the coefficients in the balanced equation to convert to what I want, which is what volume of the acid am I going to need to neutralize 50 milliliters of 0.0875 molar sodium hydroxide. All right, so they gave me milliliters, right? That's a volume, and they gave me the concentration of hydroxide. So if I convert that to liters and use the concentration of the sodium hydroxide, I can get to moles of sodium hydroxide. Then I can use the balanced equation, right? For every mole of sodium hydroxide burned up, you're burning up a mole of perchloric acid. Now I've got moles of perchloric acid. Now I can use the concentration of the perchloric acid as a way to convert from moles of perchloric acid to liters. Right, so molarity is a ratio. Any ratio is a conversion unit, right? So I could have moles in the numerator or moles in the denominator, right? Liters up in the numerator or liters in the denominator. So setting it up this way, I cancel everything except for what I want, right? Which is volume. Put in milliliters. So I could make that last conversion to milliliters. So that's how many milliliters of perchloric acid are needed. What volume of 0.128 molar hydrochloric acid is needed to neutralize 2.87 grams of magnesium hydroxide? So again, we got a neutralization reaction here, right? We've got hydrochloric acid reacting with the magnesium hydroxide. Magnesium hydroxide has 2 moles of hydroxide for every mole of magnesium hydroxide, so you need 2 moles of the hydrochloric acid to make 2 moles of water. So they gave me grams of sodium hydroxide, grams of magnesium hydroxide. So if we got grams, right, we can use the molar mass to get to moles of magnesium hydroxide. We can use the coefficients of the balanced equation to go from moles of magnesium hydroxide to moles of hydrochloric acid. Okay, and what do they want? Oh, they want the volume, right? So now we can go back and we can use molarity again, right? It's a ratio, moles per liter. So where do I want moles of hydrochloric acid? Well, I want in the denominator again, right? Put it down in the denominator, liters up in the numerator. When I multiply across, grams cancel, moles of hydrochloric acid cancel, moles of, typo, right? Should be typo fixed. So let's get back to it, right? So here's our balanced equation. We use molar mass to get to moles of magnesium hydroxide. We use the molar ratio to get to moles of hydrochloric acid. We use the concentration of hydrochloric acid to get to liters of hydrochloric acid, convert to milliliters of hydrochloric acid. So we multiply across, everything cancels except for milliliters of hydrochloric acid. That's how we do this one. All right, with part C, if you have 25.8 milliliters of silver nitrate, if 25.8 milliliters of silver nitrate is needed to precipitate all the chloride ion in a 785 milligram sample of potassium chloride, what is the molarity of the silver nitrate solution? Okay, so again, we have a precipitation reaction where silver nitrate is going to silver ion is going to precipitate chloride. So they gave us milligrams of potassium chloride. So that's where we start, right? If they give you milligrams, right? 1,000 milligrams in a gram. Once we're in grams, we can use the molar mass to get to moles of potassium chloride. Then we can use the balanced equation, right? For every 1 mole of potassium chloride or chloride burned up, I mean, there's 1 chloride for every mole of potassium chloride, you need 1 mole of silver nitrate. Now we're in moles of silver nitrate. Now we go back and we say, okay, so they wanted us to get to what the molarity is. All right, and we had to use 25.8 milliliters. So if we divide moles by, well, we need it in liters, right? So convert milliliters to liters. If we divide moles by liters, that gives me a concentration unit. Right, so 1 over 2.5 milliliters, right? Volume divided into moles will give us molarity. Right, make sure it's in the right unit, right? Moles per liter. And that's how this works. Everything cancels except for moles of the silver ion you're using and how many liters of solution you have. So you get the molarity. Looking at D, if we have 45.3 milliliters of 0.01 molar hydrochloric acid needed to neutralize a solution of potassium hydroxide, how many grams of potassium ion or potassium hydroxide must be present in the solution? Nicely, these are, it's for every 1 mole, it's 1 mole of hydrochloric acid reacting with 1 mole of hydroxide to make 1 mole of water. I mean, that's the neutralization here. The others are spectators. So I've got 45 milliliters of a 0.08 molar hydrochloric acid solution, right? So I convert to liters. Liters times molarity gives me moles of hydrochloric acid. According to the equation, for every mole of hydrochloric acid, you're burning up a mole of potassium hydroxide, right? So now we're in moles of potassium hydroxide. If we want to get to grams, we use the molar mass, right? So put moles of potassium hydroxide in the denominator. What we want to get to grams of the numerator. And I get to grams of potassium hydroxide.